Graphs of the sine and the cosine functions. This video will help you understand the graph of y equals sine of x and the graph of y equals cosine of x, as well as graph variations of y equals sine of x and y equals cosine of x. Alright, let's take a look at the graph of y equals sine of x. So let's go right back to the basics in the beginnings here. On our unit circle over here, sine of x is all of our y coordinates as we travel around the circle. So if we start here at an angle of 0, our y coordinate, notice our y coordinate here is 0. And as we travel up the circle, the y coordinates now increase. And you can see them increasing here. 0, 1/2, square root of 2 over 2, square root of 3 over 2, increasing all the way up to a maximum value of 1. And then as we keep traveling around the circle, my y coordinates then go down, traveling back down to 0, and then becoming negative. Notice as soon as I cross the x-axis here now, my y coordinates are becoming negative, traveling all the way down to a minimum value of -1, and then coming right back up to 0 again. So what we do when we graph this y equals sine of x, we put our angle measures on the x-axis. Notice here are my angle measures: 0, pi over 6, pi over 3, pi over 2. Just like this: 0, pi over 6, pi over 3, pi over 2. So on the x-axis are my angle measures. On the y-axis are my y coordinate values as I travel around the circle. Notice this angle of 0, we're starting at 0. Pi over 6, we start to increase a little bit. We increase all the way up to get to pi over 2. All the way up till we get to pi over 2. Then we start to decrease as we come around the circle this way. Then we decrease back down to 0. Now we go to the negative y coordinate values. So sine will be negative all the way till we reach a minimum value of -1, then increase back up to 0. And this cycle will continue on and on forever. Every time we travel around the circle with a higher angle measure, we'll just keep traveling around the circle and repeating this same period. So we say that one cycle is called a period, and the period takes place one time around the circle, which, remember, in radian measure is 2 pi. Okay, here's some properties. I mentioned a couple of these, but here are some more properties of the graph of y equals sine of x. The domain, no restrictions on our angle measures here. There's no place where it's undefined. So we go from negative infinity to positive infinity. The period, every time it repeats itself, is 2 pi. The range is -1 to +1, like we talked about. And here's another little tidbit here for you. The sine function is an odd function. So if I take sine of negative x, it gives me negative sine of x. And here's a little better graph, or here's a little more complete graph of the sine of x. This is the period we looked at in our last graph, 0 to 2 pi, but again, notice it just continues on and on and on. And we call every one of these cycles a period. All right, now let's take a look at the graph of y equals cosine of x. Well, very similar to sine of x here, we're going to start and travel around the circle with different radian measures till we complete one full cycle, which is also 2 pi for the cosine. But notice now the cosine is my x coordinates, not my y coordinates. So notice the cosine starts out at its maximum value of 1, then the x coordinates start to decrease from there. As I travel closer and closer to the y-axis, my x coordinates go to 0, and you can see right here, starting out at 0, we start at 1, its maximum value, then we decrease at pi over 2, we get back to 0. Now we're going to travel to negative x coordinate values. So you can see here traveling to negative x coordinate values till we reach a minimum value at pi. Right here is my minimum x coordinate value of -1. Then it will start to increase again back to 0. You can see me increasing back to 0, and then finally increasing back to its maximum value of +1. All right, some properties of the graph of y equals cosine of x. Again, the domain, negative infinity to positive infinity, has exactly the same period as the sine graph since we're traveling around the same circle. The range, -1 to +1, and the cosine function is even. So if I take cosine of negative x, it's the same as cosine of x. And you can see that right here in my graph. If I took, for example, this value right there, which would be a positive x coordinate value, and I came over here to the negative x coordinate value, it would give me exactly the same y value there. So cosine is an even function. All right, now let's look at graphing variations of the sine of x and the cosine of x. What we're going to do now is shift these graphs the same way that we've shifted other graphs in the class. So let's take a look here first at the sine of x, and let's talk about all of these values. So my value a out front determines the amplitude of the sine function that we have here. Now normally, if I made a little sketch of the sine function, it goes from +1 to -1. That's my range output. Starts at 0, travels up to its highest. That's my normal sine function graph. If I have a 1 or no number out front, that's what I get for my sine function. But if I change this value out front, then this amplitude will either increase or decrease. Notice if I change this to a 2, now instead of going up to 1 and down to -1, my graph would travel from 2 to -2. So that's how that A affects the amplitude. And if I had like a half out front here, then instead of going from -1 to +1 to -1, it would just go from +1/2 to -1/2. So that's our amplitude shift. Let's take a look at D right here. This is our vertical shift, and this is very similar to all the other vertical shifts we had with graphs. If I add a value or subtract a value on the end, what it will do is it will take this whole graph and shift it up however many units or shift it down however many units. For example, if I had a +1 on there, what it would do then, instead of traveling from 1 to -1, it would shift this whole graph up 1 unit, and it would travel from 2 down to 0. So it will reach a maximum value of 2 then and come back down to 0 as its low point in the graph. So vertical shift there. B, X, and C, what B does, B affects the length of the period. So the normal period for the sine and cosine is 2 pi. If I put a value greater than 1 there, like a value of 2 or 4 or something like that, what it's going to do is it will shrink the period because it will make this whole cycle happen faster. For example, if I put a value of 2 in there, every x coordinate I put in, every angle value I put in there would automatically get doubled. So what that does is it makes you go around the circle twice as fast. So instead of having a period of 2 pi, you would have a period of just pi. So that's what B does. B affects the period length. C is very similar to what we've done before. Remember, if we had in our graphs x minus or plus some value that was associated with the x value, this shifts it either left or right. Now, these two values, B and C, work together. So it's easy to understand what each one will do individually. But when we go to actually calculate those shifts and the period changes, we actually look at them at the same time. And the way we do that is right down here in step 3, which is identify the period and phase shift. We do that together. So what we do is we take this bx minus c, whatever I have inside the parentheses here, and I put it in this double inequality. I put it between the normal period values. Notice for both sine and cosine, period value is from 0 to 2 pi. So I put that bx minus c in there, and I solve this double inequality. When I get done solving that double inequality, it will give me my new starting point and my new ending point for one period of the graph. This doesn't make sense right now. It will when we take a look at an example. Okay, once we find the amplitude, the period and phase shift, and any vertical changes, then what we want to do is we want to find these 5 key values or 5 key points on our graph. And our key points are just this. Let's take a look back here at this first graph I made. It's where it starts, where it ends, where it reaches its peak and valley, and where it comes back to the middle. Those are my 5 key points that I need to find. Once we find those 5 key points, we simply just go and freehand sketch the curved values, a nice smooth curve between those values. All right, let's take a look at an example now that will help you understand how to graph a sine function that has some variation. So here are our steps down here. And we'll list these on both the examples and the practice so they can help kind of lead you and guide you. All right, first thing we want to do is identify the amplitude. So normal amplitude is between 1 and -1 for the sine. Here, since I have this 3 out front, I'm going to have an amplitude of 3. And what that means is I'll be traveling from 3 to -3, just according to that amplitude. The next thing I want to look for after I do my amplitude is see if there's a vertical shift here. And there's no vertical shift. Notice all of these values are inside the parentheses. If there was a vertical shift here, it would be outside of the parentheses. What that vertical shift would do would then adjust this normal amplitude range here. But since there's no vertical shift here, my graph is going to have a maximum of 3 and a minimum of -3. Now let's go to the inside here to figure out our phase shift and our period. And like I mentioned before, we do this together by looking at our double inequality here. So I'm going to say 0 is less than or equal to 2x minus pi over 3 less than or equal to 2 pi. These n values are the normal starting point and ending point for the sine function. That's where those come from. This, when I solve for x in here, it will give me my new starting and ending points. So let's see. First thing I'll do is I'll add to get rid of this pi over 3. Less than or equal to, so now I have pi over 3, 2x in the center here, less than or equal to. Well, we're going to have to get a common denominator to add those. So I'm thinking this, 2 pi over 1. I want it to have a new denominator of 3. So I just multiply the top and the bottom by 3. So 6 pi over 3. That's what 2 pi is. Now I want to take that 6 pi over 3 and add it to that pi over 3 there. So it will be 7 pi over 3. Getting closer to solve for this x now, I just need to get rid of that 2. So you might think, all right, divide by 2. Well, since I have other fractions in here, it's going to be easier if I just multiply by a half to get rid of that. Multiplying by a half is the same as dividing by 2. So I'm going to take all of these and multiply by a half. All 3 values here. When I multiply the first one by a half, I'll get pi over 6. Just x now, when I multiply that by a half. And here, 7 pi over 6. So now that I've solved for x, this tells me that on my graph, I'm starting my graph at pi over 6 because it's been shifted to the right a little bit. And I'm ending my graph 7 pi over 6. Now what I need to do is I need to find my 5 critical points here, 5 key points. Well, I've already got 2 of them, the start and the end. What I want to do now is I want to find halfway between here, and then I want to find halfway between there, which is a quarter along the way. This is very similar to how we make a ruler. So I want to find these values. So what I need to do first is find the overall distance. Let's find that overall distance here. So if I start at pi over 6 and travel to 7 pi over 6, that's a distance of 6 pi over 6. I know that because I just simply did subtraction. 7 pi over 6 minus pi over 6 is 6 pi over 6, which means this overall distance here is just pi. So I'm going to want to find, to get this point here, I'll have to find half of pi. To get this point here, I'll have to find a quarter of pi. Well, I think it's easier just to drop down to that smaller increment there, which is a quarter of pi. And then I'll just start here with this one, add a quarter of pi, add a quarter of pi, add a quarter of pi, to get all those places. So let's see, if I take 1/4 of pi, I'm going to get pi over 4. That's how I got the pi over 4. 1/4 of pi. Okay? Now, I want to add that to the pi over 6 to get this next value, because that's what that distance is going to be, a quarter of pi there. So I'm going to add that to pi over 6. Looks like a denominator of 12 for both of those. Let's see, this one I had to multiply by 3 to get to 12. This one I had to multiply by 2, so that's 2 pi. So it looks like this value right here is going to be 5 pi over 12. Okay, so right now I'm at 5 pi over 12. Well, to jump this next amount here, we said that's a quarter of pi. So I'm just going to add another quarter to that. So I'll have 5 pi over 12 plus a quarter of pi, which is 3 pi over 12. All I did was take the 1/4 now and multiply the top and the bottom by 3 to get a common denominator. So this would be 8 pi over 12. Now I want to add a quarter of pi again. Well, this is what a quarter of pi looks like. It's 3 pi over 12. So I'm going to add 3 pi over 12 to that, which will give me 11 pi over 12. So just to recap, what I did is I looked at the overall distance from the start to the finish. I found out that was pi. I need to divide this into 4 equal parts. So I take this and either divide by 4 or multiply by 1/4 to find out that this quarter pi is the distance between each of these things. Then I just start here, add a quarter of pi, add a quarter, add a quarter, and I'll get to this one at the end. Now, one thing we want to do, it's easy to make mistakes as we do these fractions, we want to make sure this distance is uniform. So notice, let me think about this one. This is what I would kind of think here in terms of twelfths. This would be 2 pi over 12. These are my little thought bubbles here. This would be 14 pi over 12. Let's make sure all of these increments are the same. Notice if I go from 2 pi to 5 pi, that's 3 pi over 12. See that? 3, 3, 3, 3. I know that I've got this all set up correctly then. Okay? Now, let's get rid of all of this stuff because we're getting ready to make our graph. I've got my 5 critical points now. Now I want to go back and think about the sine. Well, actually before that I want to look at my amplitude now. Instead of going from 1 to -1, this guy's going to go from 3 to -3. Okay? Now let's go back and think about the sine in our unit circle. Okay? So the sine is my y coordinates. So they start out at the lowest value, or not the lowest value, but in the middle or 0 value, and then travel up to the highest value. So this guy's first point is at 0. Then it travels up to its highest value when we get right here. Then we're going to come around now and travel back down to the middle value, or 0. Then I'm going to travel down, go to its lowest negative value, and then back up to 0 again. And now once I get all these dots in there, I just connect them with a smooth curve. Let's take a little closer look at our answer there and see what happens now. Remember 3 was our amplitude, which gave me +3 up, so -3 down. There was no vertical shift. If there was a vertical shift here, this whole graph would have been either shifted up or shifted down. It would have been exactly the same, except it would just been shifted vertically. These two combine together to give me my period length. And notice, like I mentioned before, since this was a 2, it's going to make this whole sine cycle happen twice as fast. So instead of a normal period of 2 pi, notice here we just have a period of pi, since that 2 makes it happen twice as fast. This is a shift in the x direction. Notice since it's negative, it shifted the graph to the right. But also notice this. This is pi over 3. The way it actually shifted the graph to the right was only pi over 6. So as I mentioned before, these two work in conjunction. And that's why we look at them at the same time together to get that shift. All right, now it's time to practice. So let's talk about this practice question and get you a little started here. Notice I've got an amplitude shift of 3/2, which is really just 1.5. So that's going to adjust the amplitude. I don't have a vertical shift at the end here, so we don't have to worry about that. But we do have a period adjustment here, and we also have a shift in the x direction. Looks like this one's going to go left in the x direction since we're adding pi there. All right, let's go ahead now and pause your video player and answer this practice question. Okay, let's start with the amplitude here. So the amplitude is 1.5, which means this. We're going to travel from 1.5 to its highest level, to negative 1.5 at its lowest level. There's no vertical shift, so we don't need to shift these values up or down. Let's go ahead and look at the middle here to find out our period and phase shift. So I write a double inequality. Just like the sine, the cosine's normal period is between 0 and 2 pi. So we put those values there. Now we're going to go ahead and solve this. So subtract pi. And then let's see, negative pi and pi here. I want to go through and divide everything by 2 now, or multiply by 1/2, either way. So it looks like my graph is going to travel from negative pi over 2 to positive pi over 2. Let's go ahead and sketch this guy out now. So here's 0. Here's my 0, and let's say here's negative pi over 2. And here's positive pi over 2. All right, so I found 2 of my critical points. Let's look at the overall distance now. From negative pi over 2 to pi over 2, that has an overall distance of pi. Now I want to divide that distance into 4 equal parts to find out each one of these quarters. Well, if I take pi and divide it into 4 equal parts, that will be the travel distance between each of my key values. So I've got a key value here, one in the middle, right? First we cut it in half, then we cut the half in half. So there are my 5 key values, and notice between each of those values now I know it's going to be pi over 4. So I want to add pi over 4 here, add it again, add it again, add it again. Okay, so I'll take negative pi over 2 plus pi over 4. Well, let's get a common denominator here, which is 4, which means I'm multiplying the top and the bottom of this by 2. So that was negative 2 pi over 4. When I add pi over 4 to that, I'm going to get negative pi over 4. So that's negative pi over 4. And then if I add pi over 4 again to the negative pi over 4, I'll get to 0. Good, that makes sense. Then I'm going to take 0 plus pi over 4. Well, that will get me to pi over 4 as well. So make sure these distances are all the same now. That's pi over 4, pi over 4, pi over 4, pi over 4. Yep, I've got it all split up correctly. Now we're ready to graph it. Let's go back to our amplitude here. It's going to go from positive 1.5. So let's see, there's 1, there's 2. So let's say right there is positive 1.5. And I would want to put this on my graph so my reader would know that, where I'm traveling from. Negative 1.5. Okay. We're graphing the cosine function now, so that's a little different. Let's go back to our unit circle and think through this. So remember the cosine function are my x values, and so notice my x coordinate is going to start out at its highest possible value to begin with. So my x coordinate starts out here at its highest possible value. Now my x coordinates decrease back down to 0. Notice my x values here are going to be 0, so it comes back down to 0. Then as I travel my next quadrant, it's going to go to its lowest possible value down here. Oops, I made this one a little high, sorry. All right, there we go. Okay, lowest possible value. Then now it travels back to 0 for an x-coordinate. My x-coordinate then is 0 back here. And then it travels back up to its highest possible value right here. So connect this with a smooth line here. And there's one period of the graph of this altered or variation of this cosine function. All right, and I've just kind of listed here again. Notice our amplitude of 3/2 took us up to 1.5 right here, down to negative 1.5 as discussed. The overall period again was just pi, because notice we had this 2 out front, which makes the cycle happen twice as fast. So the overall period then is half as long. This pi over 2 shifted it left, but notice it didn't shift it left a full pi, it shifted it half of that. It only shifted it over negative pi over 2 instead of a full pi, again because these two work in conjunction. Let's pause your video player now again, And to this practice question, notice now I've given us a little vertical shift here. So notice our amplitude would normally go from +2 to -2, but this is going to jump the whole graph up 1 unit. So if I jump 2 up 1 unit, it's going to go from 3, 2, and I also have to jump this value up 1 unit, 3 to -1. So these two work in conjunction as well. And so first we look at the amplitude, then we make adjustments over here with the vertical shift. So go ahead and pause your video player now and answer this question. And the amplitude and vertical shift take us now from 3 to -1 in the values. All right, let's go ahead now and look at our period and our phase shift. So 0 less than or equal to 1/2 x minus pi over 2 less than or equal to 2 pi. Again, cosine, the normal period is 0 to 2 pi, so that's where those values come from. Okay, so first we'll add pi over 2 to both sides. Well, that's easy on the left side. A little trickier on the right. Let's see, think about that as over 2. That would need to be 4 pi over 2 for it to be equal to 2 pi. So I'm going to take that 4 pi over 2 and add it to the pi over 2, and that is going to give me 5 pi over 2. Okay, now I want to get rid of the 1/2, so I'm going to multiply by 2. So I'm taking all of this thing and multiplying by 2. I'll think of it as a fraction since I'm multiplying it by fractions. So when I go to multiply here, the 2's divide out and leave me with just pi. Here, the 1/2 divides out, leaves me with x. Here, 2's divide out again and leave me with just 5 pi. All right, I come over here to make my graph. Looks like I'm starting at pi, ending at 5 pi. Now, let's get this on there as well. I've got amplitude and a vertical shift. So at the highest, my graph is going to be 3. 1, 2, 3. At the lowest, my graph is just going to be -1. Now, we want to draw kind of a middle line between there. So let's see, what have I got here? I've got 1, 2, 3, 4 units. So the middle of that is going to be 2. So I want to draw kind of a dotted line, and you want to put this on your graph. This helps your reader kind of see the middle of the of your graph here. In terms of vertically, it gives us kind of the vertical middle of our graph. It'll help us graph it too, and you'll see in a second. All right, now this is where my graph is going to start. This is where my graph is going to end. I want to split that up. So let's first cut it in half. This overall is a distance of 4 pi. If that's 4 pi, then this is 2 pi. So that would be pi plus 2 pi, 3 pi. This is an overall distance of 2. So if I cut that in half, that would be 1. So this would be 2 pi. And then here, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. So that was another way of doing this. You can kind of think about splitting it in half and then splitting those halves in half again. And sometimes that's easy to do. If you didn't see that, just take this overall distance here. You'll see this overall distance here was 4 pi. Take a fourth of that, and you'll see that the distance between each of those key points would have been pi. That's the way I showed you before. So you could do that as well. The other way to do this is split it in half, split the half in half again. A lot of times that's easier, especially if we're not dealing with fractions here. Okay, I've got my key points. I've got my highest values, lowest values, my middle line drawn in there. I'm ready to graph this thing. So let's see, what are we graphing? We're graphing the cosine. And again, cosine starts at its highest x coordinates and then travels back to 0. So I would say, all right, at the start of our graph, it's going to be at its highest point. Then it's going to travel back to 0. Well, now 0 is a little funny because it's not 0. It's the middle right there because it's been shifted, right? That's why it's important we get that line in there. It's kind of like my 0. Then from here, it's going to drop to its lowest value, which would be right here at -3. We'll put the -1 dot there. Then it's going to travel back up to its kind of 0 spot there, or the middle spot, and then finally end at its highest value. All right, let's take a look at our final practice question here. And this one incorporates just about all the variations we can. So if you can get this one, you definitely got it. One thing to be careful of here, and that is I got a negative value out front. So normally with the sine, we would be starting 0 and then increasing. Well, that sign there, that negative sign, is going to have us then get the opposite y value. So you want to be careful of that as you're going to make your graph. Everything else is going to work the same, but when you go to make your graph, you're going to want to be conscious of that negative sign. All right, go ahead and pause your video player now and give this a shot. Okay, let's take the amplitude and vertical shift and put them together. So the amplitude is negative 1/2. So it would be starting at negative 1/2 and kind of going to a positive 1/2, the reverse of what we had before, because of that negative sign. But now we've also got this vertical shift of -1, which means we're going to drop these values down. So let's drop this down by -1, which would be -1.5. And when I drop this down by -1, it would be to -1/2. So my values here, when I combine the amplitude and the vertical shift, is going to give us this -1/2 to -1/2 in terms of its travel up and down. Okay, let's take a look now at what happens left and right here. So same as always, we're going to put that between 0 and pi/2. All right, and we're going to solve this guy. So I'm going to add pi/3. So that would be pi/3 less than or equal to 2x less than or equal to, well, let's figure out what that is. That's going to be 6 pi/3. Yep, if I divide that, it'll give me 2 pi. So I'm taking that and adding it to the pi/3 to give us 7 pi/3. All right, to get rid of the 2, I'm going to multiply everything by 1/2. So pi/6 less than or equal to x less than or equal to 7 pi/6. Okay, let's come over here and make our graph. I think this is very similar to the question we just had before. So let's see, we're starting at pi/6 and going to 7 pi/6. 7 pi/6. All right, let's find the overall distance there. All right, pi/6 to 7 pi/6, that's a distance of 6 pi/6, or just pi. Now, I want to cut that into 4 equal parts, so I take pi and divide it by 4, which gives me pi/4. That's kind of the magic increment I want to go by here. So let's see, we're going to take this. There's our middle, and then there's our middle of that. And each one of these jumps is going to be pi/4. So I take pi/6, add it to pi/4. Well, let's see, I think we're going to change those both to 12. So that's going to be 2 pi/12. And that, when I multiply top and the bottom by 3, will be 3 pi/12 to give me 5 pi/12 here. Now I want to add another pi/4 to that. Well, this is pi/4, right? It's right there. That's what I did when I changed that to 12. So that's what it was. So I want to take and add another 3 pi/12 to this, which would give me 8 pi/12. Then I want to take and add another 3 pi/12 to this, which will give me 11 pi/12. We could go back and simplify this guy down. Notice I could divide a 4 out of there, but that's fine. I think you can leave them unsimplified. I think it's easier to kind of see it. So let's erase this. Now let's go to make our graph. All right, looking here. So this thing has a maximum value of -1/2. So let's see, here's 1, 2, 3, 4. A maximum value of -1/2 right there. And then a minimum value of -1/2. Yeah, I'm going to have to make my scale different. So that may happen to you as well. So let's change that scale. That was going to be too hard to make that graph. Let's say here's 1 and here's 2. That looks much better. So our maximum value now is at -1/2. our minimum value is at negative 1.5. Okay, we're looking at the sine, so it starts sort of at our middle value. Well, let's find our middle value. That's going to be at 1 here. So we're at negative 1/2 to negative 1/2 to negative 1.5. That puts my middle right at negative 1. So let's draw a dotted line there. We'll need that. So sine starts at its middle value, right there. And then normally it would be traveling up to its highest value. But because we've got this negative sign out front, this guy's actually going to go down to its lowest value to start. Then it's going to come back to 0. So then we're coming back to its middle spot. Now I'm going to get negative y coordinates here, but the negative y coordinates, when we reverse them with that sign, will become positive. So this guy is going to climb up to its highest value there, and then come back down to its middle value. All right, if you got that graph correct, you're ready for it. If you missed a couple things on there, that's okay. When we start our My Math Lab assignment tonight, we aren't going to start out with anything this complicated. We'll start out with some much simpler shifts and kind of build our way up to this problem. So you should be fine working your homework.